No, it's recording. Yes. Good morning, everyone. Welcome to today's lesson about integration, differential equations, and some different questions of integration. So first of all, I'm going to do question 2. Which one? 2A. It was from yesterday. Right. Oops. Okay. Right. So the question is, question 2A is dA over dt equals 6 root A, where t equals 5 and A equals 400. Remember, we said these two values, we will use it at the end when we finish solving the question. Okay, so, right, let's put this away. So what we do here, first of all, we need to separate. Remember, we need to separate the A and the T's. So I have dA on the left. I will bring the root A to the left. So this is going to be, and multiply both sides by dt. So I will have dA over root A equals 6 dt. Okay, root A means A to the power half. So root A means A to the power 1/2. Then therefore 1 over root A is A to the power minus 1/2. Okay, so we can write it down now as integration of A to the power minus 1 dA equals integration of 6 dt. Okay, so when we integrate this, so when we integrate this, that's going to be A to the power minus 1 is like you add 1 to the power, so it's A to the power half divided by what? So it's A to the power half divided by half, okay, equals 6t plus c. So this is going to be is 2 root A, basically. So 2 root A equals 6t plus c. And therefore, root A equals 6 divided by 2, which is a 3t plus c over 2. And because c over 2 is a constant, this root A equals 3t plus c over 2. Then to find A itself, we need to square both sides. So we'll get, so if we square by squaring the both sides, square both sides. There's going to be A equals, and when you square this, this means all this squared. Yeah, so it's like this is the term for this squared. So there's going to be 3t all squared, which is 9t squared, 9t squared, plus 2 times the 3t times c over 2, which is, I'll call c over 2 as another constant. Let's call it d. Yeah, let's call this as d. So it's going to be 2 times the 3, which is 6td. So plus 6 dt, dt, td, whatever. And plus d squared. Okay? And this is like the general solution. And now we substitute the values of t and A. which is 5 and 400. So A is 400. So this is going to be 400 equals 9 times t squared, which is 5 squared, plus 6d times t, which is 5, and 30, plus d squared. Okay, so in this case, we rearrange, so we will get d squared plus 30d minus 175 equals 0. So now we have an equation. We can find d by expanding, factorize, or if you want to use the formula, so d equals plus minus, well, minus 30 plus minus root 30 squared minus 4 times minus 175 divided by 2. Okay, and after you solve this one, you should get d equals either 5 or minus 35. So we have two values in this case. Therefore, A, when you substitute the value of d, then when d is 5, that's going to be 9t squared plus 30t plus d squared, which is 25. Or the other A is 9t squared minus 210t plus 1225. And that's it. So that's when d is minus 35. Okay, and this is when d equals 5. So that was question 2A. Right. Another question here I told you to solve is we have question 2B. I asked you to do it actually, question 2B. I'll just do it as well. So it's dy over dx equals minus x over y. Yeah, equals x minus x over y. X equals 0 and y equals 2. And again, we substitute these two values at the end when you finish. So first thing to do is separate the x and the y's. So put the x on the one side and the y's on the other side. So this is going to be dy over y. Actually, sorry, dy y. So y dy. So it's going to be the integration for y dy equals the integration of minus x dx. Okay. So we integrate y dy, so that will be y squared over 2 equals minus x squared over 2 plus c, right? So this is, to get rid of the 2, we multiply both sides by 2. So then we get y squared equals minus x squared and plus, well, 2 times c, let's call it d, or even if you leave it as c is fine. Okay. What's that? So plus d or c. Okay. Right. So now we have y squared equals this term. I want only y in terms of x, so we'll take the square root for both sides. and therefore I will get y equals square root of minus x squared plus d. Okay, so this is the general form, general solution, sorry. Yeah, so this is like the general solution. But what they want to find the equation when x is 0 and y equals 2. So we'll substitute by y equals 2 and x is 0. So there's going to be, instead of the y, there's going to be 2 equals square root of 0, or minus 0 squared, which is 0, plus d. Change color, y. Right? Now, to find d, because it's under the square root, so we'll square both sides. Yeah, so this square both sides, then we'll get sides, right? We'll get 4 equals d. Yeah, so therefore d equals 4 basically, and or if you want, 4 equals d equals 4 squared. Same thing, d equals 2 squared, which is 4. And now we can write the equation in terms of like with the value of the d. So therefore, y equals square root of 4 minus x squared. So this is the equation when y equals 2 and x equals 0. I hope that was clear. Anyone did this question yesterday and you got this answer anyway? No. You want to answer? That's fine. Okay, question 2F, that's page 364. It's the same exercise. I'm just, because I wrote it down here on the page, so I just got to share it with you. Okay, so, oops. Is the voice and the writing are clear? Hopefully. Okay, so question 2 now, question 2F is dx over dt. So we have dx over dt equals 10x multiplied by x plus 1. Right, so in this one, and we have t equals 0 and x equals 1. Right, again, what we need to do is separate the x and the t's together. So in this case, all we need to do, bring the x's from the right side to the other side. So bring it to this to the left here. So this is going to be dx over x and x plus 1 equals 10 dt. Okay, and we integrate them both. So we do the integration for both of them. And now, as you can see, what we did yesterday, because we have a fraction here and we have two terms multiplied together, so we need to use the partial fraction. So in this case, I will leave the integration for now for a bit. We need to work with the partial fraction first, solve it, and then go back to the integration. Okay, so work partial fractions here, because we have what is it, dx over x, yeah, multiplied by x plus 1. So this is going to be so dx over x plus 1 equals a over x, plus b over x plus 1. So therefore, and the dx here, it's like multiplied by 1, so it's 1 over, yeah? So just this here, I'll just put 1. Then 1 equals a times x plus 1 plus b times x. Right. So now we need to find the values to make this in the bracket 0, yeah, to find a and b. So when x equals 0, then so when x is 0, then what we get, that means 1 equals ax 1 plus 0 here. Therefore, a equals 1. And when x equals minus 1, then minus 1, then that will be minus 1 here equals 0 minus b. Okay, so b in this case is going to be minus, sorry, plus here. What is it? Yeah, so 1 equals 0 minus b, therefore b equals minus 1. Okay, so now we got the values of a and b. We go back now to the integration. We substitute the values in the integration. So we will have here the integration will become as 1 over x, that's instead of the a, because b is minus 1, so let's write it down here first, plus minus 1 over x plus 1 dx. And this is going to be, this integration was equal 10t plus c. That's where that's our integration here, because the integral of 10 dt is 10t plus c. Okay? So now we integrate. We have the integral of 1 over x is ln x. Yeah? So that's going to be ln x. And then minus, because plus times minus 1 is minus 1 over x plus 1. Again, we'll deal with it as same as when we deal 1 over x. Yeah, so it is ln x plus 1. So minus ln, put this modulus, x plus 1 equals 10t plus c. Then when we have subtraction between the, because we have subtraction here in the middle between the lns, that means we can, according to the ln rules, we can divide them. So we can write ln x over x plus 1 equals 10t plus c. Right. So to get rid of the ln, we can take e for both sides or work with the definition of the ln, like e to the power 10t plus c equals x over x plus 1. So, or if you take e for both sides, anything will work. Yeah. So I'll write it down here, e to the power ln x over x plus 1, if you want it this way, equals e to the power 10t plus c. Or you can write it down as, from the definition, x over x plus 1 equals e to the power 10t plus c. Both are the same, yeah? You have the same results. When I say the definition, remember the ln, it means the base for it is e. And e to the power this will give you this, okay? Right, so anyway, we have this stage here. So we'll end up with this as x over x plus 1 equals e to the power 10t plus c. Right, remember yesterday we said if we have e to the power c, it means like e to the power t, 10t multiplied by e to the power c. E to the power 10t multiplied by e to the power c, and we can call this e to the power c as d or k or anything, yeah, and another letter, or a. So this is going to be e to the power c, yeah, as a d. So this is going to be, oops, no. It's d e to the power 10t. And yeah, so that's the, just a minute, where are we up to now? Right, so we have the x, yeah, so that's the general thing basically, x over x plus 1 equals d e to the power 10t. That's the general solution. And now when t is 0 and x equals 1, then so t equals 0, x equals 1, we'll substitute here, so there's going to be 1 over 1 plus 1 equals d e to the power 10 times 0, which is e to the power 0 equals 1, yeah? So therefore, so it's d equals 1 over 2, so therefore d equals 1/2, and then we can rewrite the equation again, so there's going to be x over x plus 1 equals 1/2 e to the power 10t. So this is the equation when t is 0 and x equals 1. Okay? Right. Any question?
Miss, for the last step,
Yes, for the last step. Which step?
the last red step.
Last red step. Okay. So we have the one in the rectangle. That's the final one. Before that, we have the ln e to the power x over x plus 1. So e and ln, they cancel each other. So that's why we get so that's why we get x over x plus 1 equals e to the power t 10t plus c. Yesterday we explained this. This means e to the power 10t multiplied by e to the power c, because when we multiply the power, we add the powers. Yeah, and x squared multiplied by x to the power 3, it's going to be x to the power 5. We add the powers. So that's the same thing. If we have 10t plus c, it means e to the power 10t multiplied by e to the power c.
Okay.
Yeah, and we just call it different name, like different constant as d, or yesterday we call it a. It doesn't matter, just another constant. Okay?
So it's not, there are no problem if I didn't change the c to d?
If you change this c, yeah, e to the power c. Usually we use c as a constant. This is just to show this is different than, well, why it's different, just because it's e to the power c, so we call it d. Even if you leave it as c as a constant, then it should be fine. Or a.
Just to show them, that's right?
Yeah, yeah.
Miss?
Yes.
Is there any major difference from what we learned today and yesterday?
Is
Or
there
it just
well, no. This is just to carry on with the question, and maybe we'll go through some question, or if you need any, if you want to ask anything.
Okay, thank you.
You're welcome. Right, anyone tried the questions I sent this morning? No one want to ask this question? answer this question? No?
I'm asleep already. Sorry, miss.
Right, okay. There is questions. I think they are really nice questions. I didn't go through them all, to be honest. It's page 366. It's a review exercise, chapter 23. So I will do question 7 for you from them, and question 8, 8A. 8A and question 7. And you have question 10. It's something we covered before, but just to remind you of it, I can go through one of them, and at the same time, I want you to go through it again as a homework. Take question 10 as a homework, A and C. Okay? What else? So I will do question 7 now for you. Yesterday in the lecture, I mentioned about, I don't remember the question now, it was 1 over something, maybe something like, it wasn't 1 actually. You know, when I said you multiply by 2 and you divide by 2, the answer was 1/2 something, ln, yeah, maybe 1 over 2x plus 3, whatever, I don't remember exactly, but well, how to do this, basically, actually, forget about this. We mentioned this about the ln, how to deal with it. Some questions here I have. Okay, yeah, if we have, this is the ln questions, how to deal with them. If we have the integral of 7 over x dx, okay, it's like we can't take the 7 outside, so this is going to be 7 integral 1 over x dx. And when we have 1 over x, we can just say this is ln x. Yeah, so the answer here is going to be the 7 ln multiplied by ln x, and we put this modulus plus c. Right. The next question is if we have the integral of, that was the question, not this one, but Francisco yesterday asked me about it, about the ln, and I explained it to you. I think it was first time when I explained I had a mistake, and then I went through something similar later on in the lecture. That was, and I mentioned I had a mistake before. So just to be aware of it. 3 over x plus 7 dx. Okay, again, this one we can deal with it as, to make it easier, because it is 1 over, it's in term of like 1 over x. So we can deal with it as take the 3 outside. So it's a 3 integral of 1 over x plus 7 and of dx. And this is going to be 3 ln, yeah, because this term here, when we integrate, it will be ln x plus 7 plus c. Okay? Happy? I hope so. And the next one is, which color now? Orange. The next one is integral of 4 over 5x plus 37. Yeah, it was something similar to this one. Okay, so this kind of question, what you can do, again, just to make it easier for you, take the 4 outside. Yeah, take the 4 outside. So this is going to be 4 integral 1 over 5x plus 37 dx. And then again, this is like it's same as format of 1 over x. So we can say this is ln 5x plus 37. But because we need because we need the coefficient of x or the derivative of x. You remember we have a function saying the integration of f dash x over f of x equals ln f of x, yeah, plus c. So if we have the derivative for the denominator, if we have the derivative of the denominator at the top, at the numerator, then we immediately can say this is ln 5x plus 37. So the derivative of 5x plus 37 is 5. Do we have it at the top? No. So what we do, it's like we are pretending, yeah, just to make it easy for us to be able to write it as ln, we will say it's like this is the 5, so times 5 divided by 5. Okay, so in this case, it's going to be 1 over 5 ln 5x plus 37. That's one way. And the other way I will show you as well. So it's like pretending to make this has the derivative at the top and the function at the bottom. You multiply by 5 and you divide by 5. So that's why we will get it as 1 over 4 times 5, which is a 20. Yeah, I can take the 1 over 5 outside. So it's going to be 1 over 20 integral of 5 over 5x plus 37, which is 1 over 20. Well, we can take the 5 outside as well. Yeah, so this is going to be like 5 over 20 ln 5x plus 37 plus c. If we simplify this, by 5 is 1, by 5 is 4. I think I have a mistake somewhere. Okay, another way to do it, you can just take the 4 outside and yeah, another way to do it, another method, you can just take 4 outside and do this as 1 over 5x plus 37 dx, and this is going to be 4 ln 5x plus 37 equals 4 ln 5x plus 37, and you divide by the derivative of 5x plus 37, which is 5. So we end up with 4 over 5 ln 5x plus 37. I had a mistake on the previous one. It looks like, okay, I can't think now. Oh, actually, yeah. It's like, okay, because we wrote it as ln, that means we did the 5 over 5. So we don't have this 5. Yeah. Yeah, it's just like we multiplied by 5 and we divided by 5. So we got it as the link, sorry. So that's going to be 5. Yeah, this is the 5. We got it outside, and that's the 4 from the top. Okay. Next question. I think the red one is easier anyway. So you just make it as 1 over something over x, and you take it as ln 5x plus 37, and then you divide by the coefficient of 5x, which is 5. Let's do another one, which is 4. Okay, another one is the integral of 4 over 2 minus 6x dx. Okay, and this one we can take like 2 as a common factor for the bottom one. So this like 4 over 2 is 1 minus 3x here, and this end up with 2. So it's the integral of 2 over so it's the integral of 2 over 1 minus 3x dx. Okay, right. Again, what we can do here is, yes. So what we can do here, again, we deal with it as 1 minus 3x, so it's ln 1 minus 3x. So it's going to be equal to ln 1 minus 3x, and then we divide by the derivative of 3x. We divide by the 3x, and the derivative of 3x, which is a 3. So that's why we will write it down here over 3. So it is 2 over 3. So the answer is 2 over 3 doesn't want to be 3, okay? Actually minus 3, so it's minus 2 over 3. So the answer, and plus c, final answer is minus 2 over 3 ln 1 minus 3x modulus plus c, and that's it. Okay, any question about these, about the ln questions here?
Miss, it's not that clear.
Which one?
This one, the 2 over 1 minus 3 x, the second line.
Okay, who's talking? Is it Ali?
No, Yusuf.
Yusuf, how are you? Yusuf, how are you? You okay?
Yeah, fine, fine.
The 2 over 1 minus 3x is not clear. Okay, you deal with it same as the one before, like we take the, it's okay, deal with it as, I'll write it down here if you want. Yeah, it's like 2 integral of 1 over 1 minus 3x. And in this case, yeah, you can say it is 2 ln 1 minus 3x. And then we divide by the derivative of minus 3x, which is minus 3. So it is minus 2 over 3 ln 1 minus 3x plus c. Is that better?
Yes.
Right. Yeah. So always when you have at the bottom like something with x, we can deal with it as a ln. That's that term. So if you have the derivative for it at the top, then you can deal with it as a ln. If not, well, find another way. Okay. Let's see if there's another questions here for you to do. Oh, there is another question here. I'll show you. Okay, it's the integral of x plus 4 x plus 4 over x plus 6 dx. Okay, this kind of question, because we have x at the top and x at the bottom, it's not really easy for us to solve it straightforward, and we can't say this is ln x plus 6 because we have x at the top. Okay, so we can't say this is ln x plus 6. There is a way to do this. It's a bit like tricky. What you do here in this case, you will, just to make it similar to the bottom one. So you will do it as, I want to make x plus 6. I have x plus 4. How much do I need to add to it to become 6? 2, yeah? So this is going to be x plus 4 plus 2, but I can't just add 2. Then I have to subtract that 2 as well. So just a way to trick the question. Okay, so I add 2 and I subtract 2 over x plus 6. So now I got, and that's the x. And now there's going to be, what is it? Yeah, x plus 6 over x plus 6. And minus 2 over x plus 6. This minus here, and that's the x. So far, so good? Okay.
Miss, I didn't understand.
Which step?
The second step.
Second step.
Or the first, sorry.
The first, the red one is the question.
Yeah, I know. The
Okay. Yeah.
first step.
The first step here, we just want to make it same as the bottom, like x plus 6. Because the denominator, it is x plus 6, and the top is x plus 4. We can't say this is ln x plus 6 because we have x at the top. Okay? So therefore, what we do here, you add 2 and subtract 2. And it's like you add 0. It's just a way to play the equation. So when you add 2...
Okay, but how did it become x plus 6 then?
Yeah, because x plus 4 plus 2 is x plus 6. Yes?
No, I don't get the... Isn't it supposed to be, like you said, 0?
No, don't. Well, if you just... I mean, when I say 0, it means the value for it is not going to change the equation. So we are... If you add 2 and take away 2, it's like you didn't add anything to the equation, yes?
Okay,
We
okay.
are playing with it. So this is
Okay.
x plus 4 plus 2 becomes this x plus 6. What's left from it is minus 2 over x plus 6. Okay, so I have now 2 terms, right? Then, okay, so this becomes 1 minus 2 of x plus 6 dx. And now if we integrate, what? Sorry?
No. Because it's very loud.
I don't think. Who's
Ali Hayat.
Ali Hayat is here. Wow, that's really good.
Ali, mute.
Ali Hayat, how are you? It's been really long time. You okay? Let's wait for Ali Hayat.
Ali, she can hear.
I mute him. Okay, he's in mute now. I don't know.
أهلين هلا والله معلش ضيعت ما أعرف أفتح المايك.
Welcome back. It's been a long time. You didn't join any classes before. I hope you're okay.
Yeah, fine, thank you.
Right. Well, right. Okay. So where we are? Yeah. So integration of 1 minus 2 over x plus 6 dx. Then the integral of 1 dx is x. Yeah. So this is going to be x. Excuse me. Now, minus, who wants to answer this for me? Yeah, I'll wait for you. Give me the answer for the second integral.
2 ln x plus 6.
Well done. So minus 2 ln x plus x. So minus 2 ln x plus 6 plus c. And that's it. Okay? Excuse me. Let's see if there is any other question here for you. Yes, that's a nice one. Okay. Has anyone looked at the VLE? No? What's VLE? What do you mean by VLE? Okay. We have this integral of 3x squared plus 6 over x. I'll change the color, but just let me finish this question. Right. X cubed plus 6x minus 11. Okay. So when you have a question like this, you have a fraction with terms. First of all, think about the integral of f dash x over f of x dx equals ln f of x plus c. Yeah, try to think this way. So what you do, if you see a fraction, look for the differentiation for it. Yeah, the derivative, not differentiation, the derivative for the denominator, for the bottom one. So let's see, d over dx for, this is the denominator, the x cubed plus 6x minus 11. What's the derivative for this? Is 3x squared plus 6. Yes? Yes. Do we have that at the top in this question, in this integration? Yes, we do. So therefore, this is the f prime x, and this is f of x. So what's the answer will be, Assam? Okay, not Assam. Someone else? Abdullah?
It will be ln 3 ln the denominator.
Ln the denominator plus c.
Plus c.
Excellent, Rahman. Well done. Yeah, because we have the derivative at the top and we have the function at the bottom, and we have them both. So then, therefore, we can say this equals ln the denominator, which is ln. Put the modulus here, x cubed plus 6x minus 11 plus c. Okay. So these here is just as a note for you, like information. Right, let's do something else. Let's see what else here.
Miss,
Yes.
I have a question.
Mm-hmm.
If I have a police registration for today, but
If
they
you
didn't
have what, sorry?
police registration
Yes.
today, so what should I do? So they didn't send me any cancellation or something like that.
Is there is no email or anything you can contact them with?
No, they said no reply.
To be honest, I don't know. They are in Liverpool, aren't they?
Yes.
I think they cancelled all the appointments. Ask the hub.
Yeah, I would say just ask the hub just to make sure. Well, see what they will advise you.
Okay, thank you.
Okay, sorry about that. I don't know, but yeah, ask the
No,
hub.
no.
And in that case, it's like you told them. So
No problem.
right. So we did this. We did this. What was that question? Okay, let's see. Sorry to keep you like this. I just want to look at some questions. If I give you some question now to try, yes,
Miss,
yes,
can we have a break now?
Abdullah.
Yeah, I think we need to.
Okay, go for
Few
break.
minutes.
Go for break. يلا بعد أحسن. Okay, go for break.
Thank you.
You're welcome. Bye. See you in 5 minutes, guys. Okay. Right. So on this question, we have the integration of 2x minus 1 over x minus 2 multiplied by x minus 1.
Miss, can we put x minus 2? Can we separate x minus 2 and x minus 1?
Yeah, how you separate them?
But the same numerator?
Yeah, so basically we will use the partial fraction.
Yeah.
Okay? So we can say this means the integral of a over the integration or integral of a over x minus 2 plus b over x minus 1 dx. So now we will stop the integration bit. We need to do the partial fraction first, and then we work it out. So let's say let 2x minus 1 over x minus 2 x minus 1 equals a over x minus 2 plus b over x minus 1, and therefore 2x minus 1 equals a, after like the denominator, we make them both same, so we end up with a multiplied by x minus 1 plus b multiplied by x minus 2. Right, we need now to make them equal 0 to find the values of x, of a and b. So when x is minus 1, so when x is minus 1, what we will get, let's go back here. So that will be minus 1 times 2 is minus 2, minus 1 is minus 3 equals minus 2a plus, sorry, no. X minus 1 is actually x plus 1 should be. Yeah, sorry, x equals 1. I wrote it one way, I say minus 1. Okay, so it's, what is it? 2 minus 1 is 1. I'm looking at the x as times, so so 2x, so that's 2 times 1 is 2 minus 1 is 1 equals, this is going to be 0 and minus b, minus 1b, okay? And therefore b will be minus 1. Okay, and now when x is, x in this case now is going to be 2, then we will get a equals a 3. So when x equals 2, then this is going to be 4 minus 1, which is 3. Okay, so this is going to be 3 equals 2 minus 1. 2 minus 1 is 1a, so a and plus 0, therefore a equals a 3. Okay, so these are the two values we found of a and b. Now we will write them back on the fraction. So this is going to be, therefore, so our integration of 2x minus 1 over x minus 2 x minus 1 dx equals the integration of, instead of a, we will put 3 over x minus 2 and the b was -1, so instead of plus b, it's going to be minus 1 over x minus 1. Okay, dx. And now we will find out the answers. Let's see who wants to answer this. Franciscus, the first one.
Yeah.
Yeah, what's the answer going to be for the first integral here? For this
3
one?
ln x minus 1.
And Franciscus. Abdullah.
3. We put it 3 in the outside, can we?
Okay, yeah. And then? And then?
3 ln x minus 2 minus
Excellent.
ln x
So,
minus 1.
so 3 ln modulus x minus 2. Yes. Well done. Thank you. Minus Abdullah
Minus
now?
ln.
Okay, yeah. Carry on for that, Francisco. Minus ln.
Okay, minus x minus 1.
Excellent. Yeah.
Plus c, isn't it?
Yes. Because there is no limits in the integration. Well done. Thank you. Excellent. Right. And then there is something else we need to carry on with. Yeah, as you can see, maybe, or you notice, there is a minus sign between the lens. So what does that mean?
To
Division.
the power of -1.
Yeah, so that means we can divide here. And also because we have this lovely 3 at the front, yeah, we can put this as a power here for the length. So so this equals the 3, no, not 3. It's ln x minus 2 cubed minus ln x minus 1. Well, we can put the modulus, well, yeah, plus c. So again, because there is a minus here, therefore we can make it as a division, and this will be ln of x minus 2 cubed, so you like it this way, over x minus 1 plus the lovely c, and that's it. Okay? You like this question? Okay, let's do another one. Are you tired now? Say no. Okay. You took a break. I didn't take a break. I was checking the other questions. Let's do this. Find the integral of 6 over 4x squared minus 9 dx. Okay, so have a think about this. What do you see as the denominator? How does it look like? Think about it. Right. So as you can see, we have 4x squared minus 9, which is the difference between 2 squares. Okay. So we can write this in terms of 2 brackets. So this can be written as the integral of 6 over 2x minus 3 multiplied by 2x plus 3. Yeah, because it's the difference between 2 squares, so there will be opposite signs in the brackets, and dx. So now we have this. We can do similar to what we did in the previous question, which is the partial fraction, make it a over b, a and b, sorry. So we deal with the partial fraction now. So let's let's say like 6 over 2x minus 3 multiplied by 2x plus 3 equals a over 2x minus 3 plus b over 2x plus 3. Okay, and therefore, in that case, 6 equals a 2x plus 3 plus b multiplied by 2x minus 3. Okay, right, so now we need to make it equal 0 things, yeah? So substitute the values, we will get, so for the first one, okay, yeah, so we'll find the value of, well, x here, it's going to be minus 3 over 2. Yeah, so x equals minus, for this one, is minus 3 over 2. And for this one is what? Is 3 over 2. Okay, so when x is minus 3 over 2, I'm not going to through the substitution, you can just you do it yourself. After you work it out, then 6 equals 6a, and therefore a equals 1. So that's when x equals minus 3 over 2. So that's when x equals minus 3 over 2. And when x equals 3 over 2, we will get 6 equals 6b, and therefore b equals 1. So the values of a and b are both 1s. So therefore we can write 6 over 2x minus 3 times 2x plus 3 equals 1 over 2x
Miss,
minus 3. Yes,
I think there is a mistake here.
there is a mistake here where
When we substitute by minus 3 over 2, we get b, not a, and we get it as minus 1.
is it? Okay, I'm just copying from a slide, so I didn't work it out myself, but I can see when x is minus 3 over 2, a is minus 1 actually. Yes.
Yeah.
So you get it b, not a?
Yeah, because I
Yeah,
substituted
because,
first
yeah, that's right. Because a here is the x is
minus
minus
3 plus 3, it's
You're
0.
right. Ben now. Okay. So this is going to be 6b here, and therefore b is minus 1. Oh, thank you for that. And this is going to be a, and this a is 1. Yeah. So it's 1 over 2x minus 3, and because b is minus 1, it's going to be minus 1 over 2x plus 3. Okay. So now we integrate, we do the integration, and so the integral of this equals the integration of, okay, what's the integration here? Let's write it down for us. 2x minus 3 minus 1 over 2x plus 3. We can separate them as two integrations actually to make life easier for you. Yeah. Right, so now we have at the denominator, we have 2x minus 3. What's the derivative of the 2x? It's 2, okay? So what we can say here, we will write it as ln 2x minus 3, and we divide by the derivative of the 2x. Okay, so that means 1 over 2. So it's 1/2 ln 2x minus 3. Okay, this is same as when I explained earlier. It's like you're saying 2 over 2x minus 3 and multiplied by 1/2. So the 2 over 2x minus 3 will give us this form of the ln 2x minus 3, and the half is outside. Okay? So now we do this, and we carry on. This same thing, it's going to be minus 1/2 ln 2x plus 3 and plus 3. Right, again, we have the minus here in the middle. So that means what we need to do? We divide. Yes, division. So this is going to be, and this, the half, it's going to go to the power. So it will be this here as a power, this here as the power. So, or we can even just leave it at the front as well. Yeah, because both of them have half actually here. So we can take it as a common factor outside. So it's 1/2 ln 2x minus 3 over 2x plus 3. Yes?
Yes.
1/2 ln, so they have to be under one, same thing here. 2x minus 3 over 2x plus 3 plus 3. And that's it. Okay? Right. What's this? Oh, that's a bit complicated one. The most complicated. Right. I can give you some questions if you want to try. Here for you to try. And yeah, so the integral of, yeah, it's your turn here. Integral of 3 over x dx, integral of 5 over x plus 3 dx, integral of 8 over 2x minus 4 dx, integral of 4x minus 7 over 2x squared minus 7x plus 32 dx, and that's a nice one. Integral of 18x squared plus 15x over 2x cubed plus 5x. What's that? Don't ask me. Plus 5 dx. Right. There is another one here, is x minus 8 over x plus 3 dx. Yeah, this is similar to the one we did. Well, they should be all similar to what we did anyway. Yeah, but Abdurrahman, this is similar to the one you asked me about. Was it Abdurrahman who asked? Anyway. So you can try these questions. Before I let you go, yeah, I'm going to do some more questions. which question I told you, question 7 on page 366. Right, tell me what, let me stop this.
Miss, can I see the question again? Can you move up, please?
Yeah, just a minute. Okay, question 7 now. On page 366, which is chapter 23, review exercise. Right, question 7 say find the following integral. Question 7, I meant, yeah. Yeah. So we have the integration of cosine x over sine x dx. Okay, so look at the denominator at the bottom, the denominator. What's the derivative of the sine? Cosine. Yeah, do we have the derivative at the top? Yes. Can we apply the f prime x over f of x equals ln x plus c? Yes. Yeah. So f prime x over fx dx equals ln f of x plus c. Right, so this, in this case, is going to be equals ln sine x plus c. That's question 7a. Okay, question 7b. It's the integration of 20x to the power 4 plus 12x squared minus 12 over x to the power 5 plus x cubed minus 3x dx. Okay, so we look at the denominator here. So what we have, f of x here is x to the power 5 plus x cubed minus 3x, and f prime x here is 5x to the power 4 plus 3x squared minus 3. Do we have this at the numerator at the top? Similar, yeah. So if we take something common from the numerator from the top, we can get what we can get here outside. We can take 4 as a common factor, yeah. So we can write this as 4 times 5x to the power 4 plus 3x squared minus 3. Did I have any mistake here? Hopefully not. Over x to the power 5 plus x to the power 3 minus 3x dx. So now, as you can see here, we have like 4 lots of this, yeah? We have 4 of this. This is the derivative of the function. So we can say it is ln the denominator times 4. Yes, 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 yes. So therefore, we can say this is 4 this. Wow. Minus what? It looks like minus 3. Okay. So this is going to be equals 4 ln x to the power 5 plus x cubed minus 3x minus 3x plus c. Yeah, if we can do this as yeah, just 4 ln something, and that's it. That's for question 7b. Any question about it? Everyone happy? I hope so. Okay, let's see the next question here, which is question C, 7C. It's the integral of 10e to the power 4x plus 5 over 5e to the power 4x plus 10x dx. Okay, can we take anything common here? Well, let's have a look. As I said, it is a fraction, so look at the denominator first, find the derivative for it, and then see if we have the derivative for it at the top. So I'll work it out here. F of x is 5e to the power 4x plus 10x. Then f dash x is, so the derivative of e to the power 4x, well, we leave the 5 as it is, yeah? And when we derive this, it's going to be e to the power 4x multiplied by the coefficients of x, which is 4. So 4 times 5 is going to be 20 e to the power 4x plus the derivative of 10x is 10. Okay, so now we have the derivative here is 20 e to the power 4x plus 10. Do I have something like that at the top? I have half of it, yeah? Instead of 20, I have 10. Instead of the 10, I have 5. So basically, I can say this is half ln of the denominator. You with me with this step? So in this case, we will say it is half ln 5e to the power 4x plus 10x plus c, and that's it. Any question about this? Okay. I'll do question 8a. Question 8a. And I'll leave question 10 for you as a homework. I was about to do it for you. I'll leave it for you as a homework. I'll do question 8a. Okay, question 8a is the integral of 3x squared times e to the power x cubed dx. Okay, so in this case, we can say, we can use the, what's it, the substitution. So let u equals x to the power 3. Okay, and du over dx is 3x squared, and therefore dx equals du over 3x squared. You still with me? Yes, hopefully. Right, so in this case, I will substitute everything in the integration, and there's going to be 3x squared times e to the power u, and instead of the dx, I'll substitute it as du over 3x squared, so times du over 3x squared. And we can cancel things out, so 3x squared, it goes with a 3x squared here, and we end up with integral of e to the power u du. And the integration of e to the power u is e to the power u, yeah? So it's e to the power u plus c, and then we return the u to its origin, which is x to the power 3, and therefore e is equals e to the power x cubed plus c, and that's it. Okay? Oh. Are you happy for this?
Yeah.
Okay, so I hope, well, maybe, I hope you get the benefit from these questions. It's too many questions, I know. I have some more as well, but you're tired, I'm tired, maybe. So you can try question 10. And what do you think of this live session?
Yeah, it's helpful.
Helpful. So I think there is an instruction here, like I can ask you, you can ask me. And if you have anything like you find it difficult or anything, you just send me the question and I can help you with it later on. Yeah, if you have any question or if you have any problem anywhere. Yeah. And maybe I will do some trick, not now. I know maybe Abdullah soon will say we are happy. I'll give you some more trick questions to solve it with you. I mean, I did that in the video anyway. Do you have any problem with the trig integration? Like you need to use the formula sheet. You will have a formula sheet in the exam anyway. The exam, it's going to be an open book, but in a fixed time. So you will do the exam online, open book, and you have to submit your work during that time, like say the exam for 2 hours, then you have to do your work and finish and submit in that 2 hours. Okay, and something like that. So you will have you received any email about it? I think it's too early for you to receive now. Anyway. Okay, so if you have any question, feel free to ask. And nice to see you all here. And right now, if you're happy and you know it, you can go. I have Sarah, Farah, Ali Hayat, Yusuf, Ali Subih, Ali Dabri, Abdullah, Anfal, Franciscus. Who else I didn't call you? Your name?
You didn't say mine.
Abdurrahman, yeah, sorry. Yes, Abdurrahman, of course. Anyone else? No? So 3, 6, 9, 10. Okay. Well, thank you very much, and I'll see you soon tomorrow. Yes?
Yes.
That's great. Have a nice day and take care.
All right. Thank you, Miss.
You're welcome. Bye. Bye.
Have a nice day.
Thank you to everyone.